Right, hello, and welcome to the Space Engineers tutorial project. This is episode 12, and today we're going to be looking at miscellaneous blocks. In this episode I will cover a lot of blocks, so I'm going to have to quickly go over them, whereas other episodes have been very in depth into most of the things. This one is going to be a very cursory look at each of these blocks and their functions and how to use them. Some of these blocks have much more advanced uses, but if I go into that, this episode will be about 3-4 hours long. So in this episode I intend to cover antennas, both normal laser and laser antennas, beacons, remote control blocks, or detectors, control panels, pistons, gravity generators, the camera, sound block, the sensor, the LCD, the merge block, landing gears, rotors, both normal and advanced, timer blocks, decoy blocks, and button blocks. So you can tell there's a lot to go over here. First three blocks have pretty much the same functions in one respect, and that is to identify a grid and its location. You can see from the beacon here that it has a little marker that appears on your HUD. You can cycle those markers by pressing the H button for hotel, and it will go through different settings. It will have the name and a little icon. It will have just the marker, and it will have nothing that's switched off. Okay. Now, having it on like that, what I want to do is look at the beacons. I'm going to go over to this control panel here and look at the beacon. We go to the beacon, and here we can slide the radius at which it can be seen. So anywhere from 1 meter all the way up to 50,000 meters on a large grid. Okay, on a small grid, those ranges are significantly smaller. I think it's a tenth, so they can go up to 5,000, which this is 50 kilometers on a large grid. But if you do notice, when I slide this slider on the middle here, on the right over here, the power consumption goes up. So if I slide that all the way up, that requires 10 kilowatts. If I slide it all the way down here, it requires 2 watts, and so on. Yeah? And all three of these blocks, the beacon, the antenna, and the laser antenna, can be used for that purpose, to identify your grid. Excuse me. Now, the antenna, this one, in the center, has a secondary function that it needs to be attached to a grid. If you have a remote control block, which is that one over there, we'll cover in a minute, it will allow you to remotely access that grid for either piloting or other reasons, which I'll cover in a minute. The laser antenna has some unique features in it that we go to the laser antenna here, and it's a lot more complicated. Its range is infinite, but it requires a huge amount of power. It needs 100 watts when it's idle, but when it's making the connection, depending on range, this number will go up significantly. So if you what you can do with these is link two together. So if I, for instance, had this was an Earth base over there on a planet, and this was my orbital space station, we could link the two as long as they had the direct line of sight. And if I'm on the Earth planet, or say let's say I'm on the station, which is I'm on now, I could go in here, go to the laser antenna, align it by using the coordinates here with my Earth base once I have those coordinates, and then it will align, which would mean I can control the Earth base from here. So if the Earth base is where all my construction is, where all my production is, I can tell my Earth base to do production and what have you, close doors or whatever I need to do. Okay, so this does help over great distances, but they need to be line of sight, and they use a huge amount of power. Okay, next block is the remote control block. This puppy right here. Now, as it says, it does exactly what it says on the tin. It is a block that allows you to remotely control any grid that it's attached to, as long as it has an antenna. Not a beacon, an antenna. It must be an antenna. Okay. This can be used to either control a base, like we was talking about. Let's say I was in a ship and I had one of these on my main base and an antenna, and my ship took some damage, and I need to make some components to fix my ship. I could then remotely access going into K and then go here, find it, control it, and then I am now controlling the base here. I can then go to my production and say, because there's no assemblers on this one, but I could go to my production and say, right, make me all the component parts I need to fix my ship. Okay, press T to exit. Now, that scenario I gave you there, I fly back to my base and all the components are ready. Done. Perfect. What about also having the fact that with a remote control block, you can attach it to a small ship. Remote, let's type remote in here. And we can then, with this one, put it into flight mode. Autopilot goes into, let's see autopilot on there, because this is on a station, so that won't be highlighted. But if it's on a small grid, for instance, you can have it turn onto autopilot, turn on avoidance, precision mode, which is very careful, and it can actually connect and do other things. Tell its direction, where to go, the speed. You can add waypoints in here to give it a patrol route or whatever you needed to do. You could then, when it gets to the patrol, you can tell it what to do when it gets there, and it can set up actions like connect and so on. The uses for a remote control block are endless. I've played this game for nearly 3,000 hours, or probably over 3,000 hours actually, and I still learn new things you can do with these things. Okay. So that the list for what you can use a remote control block is endless. Experiment with it, try it out, see what you can do. Okay. Things to note about it is the green eye, this piece on the front, is the front. And it also has a sloped side on both sides, which the slope slopes down towards the front. It's important that a grid knows which way is front, because, for instance, if you use it to control a drone ship, and you press W, if it's the wrong way round, it won't go forwards. So your controls will be completely the wrong way round. When you try and tell it to fly to a certain place, if the remote control block's the wrong way round and it's done on autopilot, it won't be aligned correctly and so on. So always make sure you align this block with the green eye pointing forward, and the slope also is a secondary indicator. Okay. Control panels are very, very self-explanatory. They allow you to access the menus. Okay, this is a control panel here, this little piece, not the big block. You put them anywhere. They are this size, and you can put them down anywhere, and they simply allow you to gain access to your control panel. Okay, very, very simple. An ore detector like this. I put a control panel on the back because when we go into it, we go into the ore detector here. Now, it has a few little functions, but its main function is to detect ore. That's what the name tells you. It comes in large grid and small grid variants, and this slider here will tell you how much range you need to be, how far away you need to be for the ore to show up as a little white. There you go, you can see them there, iron, silicon, and so on. Because this one is using another function, which is called broadcast using antennas, once you find an ore, it will continually broadcast that because it uses your antenna. All of these settings require more power. Okay, on a small grid, this is going to be significantly smaller range than on a large grid. Okay, so remember that. Next thing I need to show you is the gravity generator. Now, a gravity generator does what it says on the tin. It generates gravity. It will generate 1G, which is 1 times the strength of Earth's gravity by default. Okay, you need to note that on the top there is a green light and there is a dome on the top also. This is important because gravity will be pulled down through the top, and the direction of gravitational force will be denoted by where the top is. So where the top is, pushing down, it's gravity. So you can see I'm floating above it. If I let go of my jetpack, I'm pulled down, because that's the direction of gravity. Okay. Inside the menus for this one, you can adjust the acceleration, which is 0.8 meters per second squared, which is 1g. You can lower that all the way down to nothing or next to nothing, which can be useful in certain situations, or you can reverse it, which, as you can see by my screen, starts to push me away. Okay. You can then also adjust the field width, height, depth as regard to the center of this block. Now, with a bit of practice and a lot of messing around, a lot of adjusting, you can actually design things that are very clever indeed. Now, I've seen one such build on the workshop where a person has built a circular ring station which they can walk around the entire ring without using their jetpack and without falling, because they have multiple amounts of gravity generators with a very tight field pulling them down, so they continually walk around. And you can do things like that. You can also use it to propulse things. Gravity generators, again, you probably want to just mess with it a little bit. Okay, now pistons. Pistons are the bane of most space engineers' lives. They can be very unpredictable, but there are things you can do with them. They are simply a tube that will extend. That's simply their function. Okay, so if I press that, this block will extend. You can have them at the diag. You can have them at horizontal or vertical, like this, and they will work just the same. Okay. Now, the basics of this thing is you can tell it how fast to move, the minimum distance and the maximum distance of these two, and that tells you how far to extend or how far to retract. You might not want it to retract all the way. If there's a block behind it, it will damage. So there's that. If these ones here at the bottom are the impulse axes, and basically that's the amount of force behind the head. For now, I would recommend you leave those alone. But what it does is imparts the amount of force the piston will use once it experiences any resistance. So it can continually push. If you use it on, say, a drill head and you put too much impulse axis on it, it will push its way through the drills or smash the drill head to pieces. So you need to be aware of that and adjust those accordingly. The reverse button here does what it says on the tin. It reverses the last action that you put in. So if you pressed it once and it will extend it, press it again, it will retract. Very, very simple. This button here, this chat box, is called Share Inertia Tensor. Sounds very complicated. What it basically does is allows all of the connected grids, so this end and that end, to share any kind of force that's imparted on either one. Now, if you're using this for just extending out a grid and having it held at a certain distance and it's not going to be moving, using the shared inertia may stabilize your grids. Okay, but if you've got moving parts on this end, like a drill head, a rotor, or anything like that, sharing the inertia means that if the drill head hits the rock and starts bouncing, does this kind of thing, that inertia is going to spread along through your entire grid, and that can cause catastrophic failures. So be aware of that. Okay, you must be aware that when you check that box, all grids attached to that piston will share the same inertia. Okay. Now, this is a camera, this is a sound block, this is a sensor, and this is an LCD. So these four I'm going to cover you through very quickly. A camera, we all know what cameras do, right? We click on the camera, We go to the view and we can see what the camera sees. Okay, we press T to come out of it. Now with the camera, where is it? There. You can zoom in and out with the mouse wheel. If it's attached to a drone and that drone has a remote control block and an antenna, if you move your mouse and use WASD, it will allow you to pilot the grid. Now for some reason I just fallen off. Give me a second, go back. That's because I wasn't actually controlling that, I was controlling my character. So when you're in remote control, if you access the camera, you'll be able to control the grid. Okay. One thing to note with the cameras, this metal bar denotes the top. For the same reasons as the remote control block, things in Space Engineers need to know which is the front and the top. Because if you've got that attached to a drone, let's say that little ship there, and it's upside down, when you press W, you won't go forward, you'll probably go backwards. It will invert your controls and it will be a pain in the backside. Okay? So the next one is the sound block, which is this little speaker here. And we'll have a look at that in the control panel here. We'll go sound block there. These are very simply a block to play sound. Okay? You go down, you select the sound you want, and you tell it how long to go on for. And that's that. Okay, you can tell it how long, how high, how long, how far away people want to hear it, how loud it's going to be. This is limited by the amount of sounds you have, and you can get some from other files and things like that. But again, that's more complicated. For now, you assign it a sound, and it will make that sound when you press play. Now, let's look at the next one, which is the sensor. Okay. A sensor will trigger another action when its designated object passes within the designated field. Okay, that's my description of it. Now, what that means is the field is here, the left extent, right extent, bottom extent, blah blah blah, all the way down. You can adjust that to be whatever you want it to be. Okay, down to 1 meter. So a 1 meter cube in all directions means it needs to get pretty damn close. You can adjust it all the way up to 50 meters. And so on. Okay. The designated object you designate with these clicks down here: detect players, blah blah blah, and also down there. Fine. So when the sensor actually detects the thing that you want it to detect, be it small grid, person, large grid, planet, asteroids, whatever, what does it do? Well, you click the setup actions and you get the same G menu that you get from the cockpit. Now let's grab the sound block, let's put the sound block on there and tell it to play. Sound block we used just now, right? So let's go away from there and then run back. The sensor picked me up and it told the sound block to play. Okay? Now you can use this in many applications. Okay, I've seen it used on a dropship where it gets to a certain distance and it will fire retro thrusters so that it will slow the object down. I've seen it used on drone mining ships, that when it gets to within a certain area of the asteroid, it will start mining, blah 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 blah. The limitations of this are limited by your imagination. It can activate any action that any of the blocks in the game can do. Let's move on to the next one, which is the LCD. The LCD is just a display. It doesn't do anything else. However, it has some features. Now, no content means no content, nothing on it. You can have it as text and images. Now, let's have the danger sign here selected and the no entry sign selected. We've got a time there of 1.5 seconds, and we're going to put some text into it with the edit text of restricted area. Okay, Now it says restricted area. Now here's a cool thing. What if we went back to the sensor and went set up actions, drop in the LCD and told it to toggle that on. Okay? If we turn this off now, watch what happens when we go around this corner. Now remember, we had the sensor with the sound block. Now we've told it, we walk around this area and it toggles on the LCD and the sound block. So that tells us a restricted area. That's one little way you can set it up. Okay. Now we can go down to the last option here, which is script. Now scripts are pre-designated set of instructions and images that will happen. Now for instance, you can have the gravity on there, and that will tell you that there's 1G. If I place another gravity generator down, that will go to 2G, artificial gravity, not planetary gravity. Okay, so that tells you exactly what's on there. You can have it tell you one of the presets is a digital clock or an analog clock. Okay, it tells you the exact time that it is here for me. It's nearly 4 o'clock in the afternoon. That's when I'm recording this episode. Okay, there is also the artificial horizon. Excuse me. If you have this on a cockpit for a ship, when you roll and pitch the ship, that will indicate on there. Excellent. Okay, next one, merge blocks. Now a merge block allows you to more permanently attach 2 grids together. That's my description. 1 merge block per grid. You align them up and they will connect, magnetically pulling each other together, and they will connect the grids together. You simply just need to align this claw-like face with another claw-like face and move them together. Being aware how fast you travel when you're connecting, that force will be imparted on both grids, so it can cause damage if you're doing it too quickly. Okay. Once they're attached, the 2 grids will become one, essentially. They will share inertia, dampeners, thrusters, directions, all of those things, power, everything. And if you have a connector up here on this block, for instance, and another connector on the other one, when they connect together and these lock together, you can share inventories. You see? So merge blocks are useful for that. Now, rotors. Rotors come in 2 different types. They come in normal and advanced. Let's look at a normal one first. And they basically, well, both of them have the same function. They turn things. Okay. Now this rotor, as you can see on there, there are numbers marked on the rotor head. Okay. The 0 is the 0 degrees. They are in increments of degrees in a circle. So the maximum is 360. Okay. So that is. And this one will rotate clockwise by default. Okay, if you put in negative, I'll show you in a minute, that will go opposite direction. Now this one, this is 0. So when we go into the controls for the rotor, let's put a control panel on there. We will go to rotor here, normal rotor, and you have all of these controls that you can do. Now you can detach the head, not always advisable. If your rotor head gets broken, you can put another head on, or if you want, for instance, we showed you in the building episode, you can attach a small head to a large rotor to allow you to make small grids on a large rotor. Now, torque. This is the first one you need to adjust. Torque is the power and how fast it will accelerate when the rotor is turned on. Okay, if you put too much torque on this, it will spin. It will accelerate to the maximum velocity you put in very, very quickly. Okay, the opposing force to that is braking torque. Now, one thing about torque is very important to understand. If you have too much braking torque and you've got a very heavy object on the end of the rotor, the object will decelerate very quickly, but the inertia will keep going, and that could likely snap the rotor head off. So you need to be very careful when you adjust these, to adjusting them for weight, speed, etc., etc. So talking to speed, there's velocity. Velocity is how fast the thing will travel. Okay. The torque is how fast it accelerates to get there, so the amount of power to push through it to get it that fast, and that's how fast it will end up going. The lower limit and upper limit there, they are basically, you can set a rotor to only turn through 90 degrees. Or if they're both set to 0 and you impart some velocity and on this thing, it will spin constantly in a circle. Okay? Depending on the speed in which you told it to go. If you have 0 braking force and velocity, and put velocity on it with no upper limit or lower limit, it will continue to spin even if you turn the rotor off. The last one there is rotor displacement, and that gives us a distance of the head above the rotor body. It's very simple. If you can fine-tune adjust your builds. If you've got two parts, one on a rotor, one not, and you want to really lower the gap, you can adjust that. Or you need to move the gap further. In this instance, what I've done is just put you a demonstration. Let's say you've got a loading bay here and your ship comes into dock and you can't get out, right? So what I've done there is just put a few catwalks on it. I would tell that to spin 180 degrees, and then that will align with the ship and you can get off the ship that way. Okay, this is a advanced rotor, all exactly the same, except it will allow items to pass through it. Now what I've done here is I've set up a tube with a connector on it. Now let's say you have very limited space here for a flying through area or something like that, and you don't want to have a connector poking out. So you could have that hidden away, turn it around, and then connect the ship, turn it back to allow the ship to pass through, or whatever you need. The rotors are up to you. You can put them horizontally or vertically and have everything spinning. So you work out what you need to do with a rotor. Okay, let's look at landing gear. Landing gear are used to cushion the landing of a craft, simply. Okay, they can automatically lock, so they have a magnetic plate on them, and they can lock to any metal surface or the ground or anything. They will lock. Or you can. I'm going to jump into the ship to tell you the rest of these because you need to see this. Landing gear. So this is the auto lock. If it comes within range, it will lock onto it, whatever it is. And if you want that on, no matter what happens, you will automatically lock. It's not always good on a landing for landing a craft, because you might have 6 landing gear and it'd be uneven terrain. Then you lock onto 1 landing gear. Okay, so you can manually lock them. If you turn this off, you can manually lock and unlock them here. You can also do the same by dragging them down onto your toolbar. In this design here, I've used them as a grabbing mechanism, because this is a tugboat. This is my Lionheart. It has a lot of thrust compared to its weight, so it can attach to much larger objects and move them around. So let's say a big ship is broken down, or I'm trying to retrieve a crashed ship, I can use this thing to do that. And I use the landing gear as grabbers. They will lock on, and then I can use my thrusters to pull it around. Landing gears can also be used to stabilize items in travel. Let's say you have pistons and rotors with constructions on them, and you want to have it moving. There's a chance that that movement could cause one of the grids to start wobbling and snap one of the grids. So you could use a landing gear to stabilize that grid. You can have it on a very long things for traveling, and when you're making movement. We discussed with wheels in the last episode about possibly a crane. You can use the gears to stabilize those, and so on. Okay, so landing gear have quite a few uses, but they're a magnetic locking device, so you can use them to lock on or just for stabilizing. They can take quite a big impact as well. Next, I want to show you the cryo chamber. This is a cryo chamber. If this was plumbed in, which we spoke about in the automation video, this will replenish all of my bars, my hydrogen, my oxygen, and my energy. It won't regenerate my health. You need a med bay for that. The other main function is when you get in it, it saves your character. So any object, anything I'm carrying in my inventory, it will save me. Let's say, for instance, you have a big ship that you're on a server and lots of different people move that ship around. When you want to log off, you jump into a cryo chamber and your friends carry on playing. When you come back to join the game on the server, you will still be in that ship in your cryo chamber. Just get out into the ship. And also saves, like I said, saves your inventory. So whatever you have, you won't lose. Because sometimes in multiplayer, when you log off, you can lose your inventory. Okay, timer blocks. That's the next one I want to show you. This is a timer block. So 2 of them here. Now, my description of this is a timer block can be used to activate any function of other blocks. Okay, much the same as a sensor, they have the setup actions. So we set up these actions, but they have a lot more on the bar. They have 9 actions. Okay, so we can drag down anything here, the sound block or whatever we want, and put them down here. And then when we do that, it gives us the same options to play the sound or whatever. Okay, now the timer block has a delay. Okay, so you can set it so when you activate it up to 1, I think that's an hour. An hour later, something will happen. Okay, or down to 1 second, which is the lowest. Okay, I'll demonstrate this later on with something I want to show you on how these work. But the other thing you can do is in setup actions is you can drag another timer block onto that bar, and then you can tell it to start. Okay, so what you can essentially have is more than as many as you want things to happen here. Again, I'll show you in a later build what I've got for those with a timer. You can have one thing happen immediately, something happen a little bit later, and so on and so on. So you can trigger now, which doesn't have any delays, it doesn't listen to the delay function you put in here. You can start it, which will, if we wait 3 seconds to start. There you go, there's the timer block. Okay, that's the timer block going off there, the sound block, sorry. Or we can just trigger it now and it starts the sound block. Okay, simple as that. That's what those buttons do. Now that's the basics of timer block. I'll show you a little bit more with them a little bit later. Now, one of my favourite blocks, and very, very underused block, is called the decoy block. This one here. These are really, really good when used against auto-targeting turrets. So auto turrets. An auto turret has its AI programmed to attack certain blocks in certain orders. Weapons, power, cockpits, so on and so on. So it will attack your weapons, it will attack your power sources, your engines, all of those kinds of things in order to disable your ship and your cockpit as well. What a decoy block does is it overrides that programming and tells it to attack the decoy block first. The example I have here, these decoy blocks are around my engines, my thrusting engines. Okay, there are more hidden in this build, which are in secret locations. Okay, but they will tell the targets to attack these targets rather than my engines, which will give me a few seconds of extra fighting time, which allow me to destroy my target and not have my engines compromised. Okay, they're not going to last forever, but it gives you a few bursts of extra time that you're not being destroyed. Okay, that's a decoy block, and they are very, very useful. Okay, last block I want to show you is the button block. Okay, and this is a button block. Here it has 4 buttons. 1, 2, 3, 4. There. Okay, on a small grid it only has 1. But what a button block simply does is it lets you do the action. So let's go into number 2 there. It brings up this again. So we could do that. No, not the camera. We can tell it to do the sound block, right? And we can put that on there to tell it to stop. So now if we press 2, hang on, let's make the sound block a bit longer ranged because we can't hear it. There you go. And we can stop it. You can do that for anything. You can turn turrets on, turn turrets off, open doors, whatever you want. It can tell a block or a group of blocks to behave in any of the functions that that block has. Right. So let's get on with a little demonstration that I've been talking about. Okay. What I'm going to do now is show you how you can apply some of these things together. What I have is a piston, which is horizontal. I have connector, and I have some forgotten the word, airtight doors. Okay, this uses 2 timer blocks. So let me show you demo. Excuse me. The demo start is the first timer block I use. It has 0 or 1 second delay. On the setup actions, what I've told it to do is I've gone to the groups, I found my door, dragged it down, and told it to open or close those blocks. Okay? So the first action it will do is to open the door. Okay? We go back, go to demo 2. The setup actions on that, I've told it to do is to extend the piston. Right? So we have 2 timer blocks. One's action is to open the door, the other is to extend the piston. Now this is where it gets a little bit clever. If we go back to demo 1, setup actions, what I've done is I've dragged down demo 2 start. Okay? So its first action will be to open the doors, and then it will trigger the demo 2 block. And if you remember, the demo 2 block has the piston on it. But the demo 2 block also has a 10-second delay. So what will happen when I press the start on demo 1, is it will open the doors, it will activate demo 2 timer block, and it will wait for 10 seconds to extend the piston. Now I've done all of this onto the button panel. So onto one button, I press the button, the doors open, which is what we had on timer block 1. 10 seconds later, once the doors have opened, timer block 2 has already been activated, but it's counting down 10 seconds. And there, the piston starts to extend. So if you imagine this on the side of a bloody great ship that you want to refuel, or you want to give some ammo or whatever to another ship, but you don't want this out in the middle of out in the open because it can get shot off, right? Or it doesn't look sleek or whatever. There you go. That's one use, putting together a few items of that I've shown you. Now, take this a little bit further. Okay, you could have that as instead of a button there, you could have a sensor up there that just detects small ships. So when a small ship that's friendly, you can tell it that much, comes close, it will then trigger that action that you've just seen there. So the doors will open and the piston will come out. That's what I'm saying about is your imagination will drive your builds. I've been banging on about that all the way through this tutorial series. I can give you the basics. What you do with it is up to you. Okay, you can have it as a hangar bay door, like those doors down the bottom there, and only your own ships come flying in. They don't have to open the door; it will open for them. And then another sensor behind it to say when it sees that ship close the thing, or on a timer block, have it open, and then 20 seconds later close the door and repressurize the oxygen, and all these things that we've spoke about before. All of those things can be done using these blocks. So you can automate and make these things as complicated as you want. Okay? So there is a brief roundup of very special blocks in Space Engineers. It takes an absolute age for me to go through them all for you. But I hope you appreciate that I've only given them a cursory look. I haven't gone into all of the applications of these things. There you go. I've just set off the the thing again, the sound block, by going past the sensor. But I hope you can appreciate that I've only gone into these things in very, very cursory look. And this video is running a great deal of time already. So I'm going to end it there. I'm going to say thank you very much. You now know enough about these blocks. And with the other tutorials, there are only a couple more to come to look forward to. I'm going to talk to you about GPS and jump drives, and I'm going to talk to you about painting and creative building. And then I'm going to show you putting it all together in a couple of survival episodes where I'm going to do a genuine survival video on a planet and a genuine survival video in space. Okay? And that's basically going to be it. So you come nearly to the end of the tutorial series. There are 2 more instructional videos, and then we're going to put them all together. So thank you for your patience, and I will see you in the next one. Take care. Ta-da.